This is Mrs. Davis. I'm working on Calculus 610 integration with long division and completing a square. This is the second video, and we're working on this problem. As you can see, I have issues. This is a little different. I have this polynomial, so I'm thinking maybe inverse tan, but then I have this x up here. Now, I also know that if I make this u, I get 2x plus 1, and so, I have an x. So, is there something I can do, and this is a trick, so this is like a 12 on the score. Is there something I can do so that I can turn this into a function I can work with? So, oh, there's my dog barking. Just ignore her. So the first thing I'm going to do is think about this. And I want my top to look like that. So what I'm going to do is I'm going to pull out a 1/2 and put a 2x here. X squared plus x plus 1. So I'm sort of tricking it to give me a 2x. And if you can see, that's the same thing. Pulling out the 1/2 and then multiplying by 2 would just go away if you multiplied it out. So I'm pretty close. Now I need a plus 1, and the only way I can do that and not change the function is to do plus 1. So I'm going to do this. I'm going to do a 2x plus 1 minus 1 over x squared plus x plus 1 dx. And now this is exactly the same thing, okay? But it looks a little different just because I put the parentheses around it. And so now we can look at it like this. I have 2 terms on the top and 1 term on the bottom. So I can split this up. So I am going to write this as 1/2 the integral of 2x plus 1 over x squared plus x plus 1 dx minus 1/2 the integral of 1 over x squared plus x plus 1 dx. Now, if you'll remember, we had that same problem, the second half of that integral right up there. And so the integral of 1 over x squared plus x plus 1 dx came out to be this beautiful thing right here, right? Let me get the yellow highlighter. So I already know the second half. That's going to be that. So I just have to work with this part. Now, if you didn't have this part already, you'd have to do this in addition to. So that's why this is a 12. All right, so let's integrate this. So we're going to let u equal x squared plus x plus 1. So du is equal to 2x plus 1 dx. So dx is du over 2x plus 1. And that crosses out my 2x plus 1's. And I can rewrite my integral as 1/2 1 over u du. Now that's just part of it. That's just that integral. We'll keep the other one so we don't mess up. 1 over x squared plus x plus 1 dx. So now I can take the integral of this one. It's 1/2 ln, the absolute value of u, and then plus c minus 1/2 integral of 1 over x squared plus x plus 1 dx. All right, and I just substitute u back in, so I get 1/2 ln of the absolute value of x squared plus x plus 1. And then I have a plus c, but up here I had a plus c, so a plus c and a plus c just becomes a c. So I am going to say minus 1/2, and then the answer to the other one was 2 square root of 3 over 3 inverse tan of 2x plus 1 over the square root of 3, and then there's the plus c for that. So let's just simplify that. I'm almost there. 1/2 ln of the absolute value of x squared plus x plus 1 minus the square root of 3 over 3, the inverse tan negative 1 of 2x plus 1 over the square root of 3 plus c. Whew. All right, so doable, but quite challenging. All right, I'm going to turn the page and see if I can do one more on this before we start a long division. All right, moving on to this example. One more when you kind of play tricks with your function. Looking at this, I have a square root in the bottom, I have an x squared. Maybe I could turn this to an inverse sine. So what I need, remember, is 1 minus x squared, the square root of. So I'm going to be working with what's under the square root to try to turn it into some form like that. So the first thing I'm going to do is say the integral of 1 over the square root. And now I am going to, first of all, I am going to pull a negative out and then turn this around so it would be x squared minus 2x. All right, and that just helps me kind of see what's going on. And then, you know, I'm going to be complete in the square, so I kind of want to have that in the right form. So I have sorry, I already had the 1. Square root of negative x squared minus 2x, that would be plus 1. And now I have to do the opposite to keep it the same. Now we really didn't add 1 because this negative out here. We really subtracted 1, so I have to put a plus 1 back. And that would come out to be the same. If you multiply that out, that's negative x squared plus 2x minus 1 plus 1. So you still get negative 2x, x squared minus 2x dx. So we're starting to look a little better. So that's going to be this is 1 over the square root of negative x minus 1 squared plus 1 dx, which goes to the square root of 1 minus x minus 1 squared dx. Now I'm looking really good. I have something squared, so if I want that to be a u, I'm going to use u substitution. So going over here, we let u equal x minus 1, so du is dx, so that's nice. So with my u substitution, I have 1 over the square root of 1 minus u squared du. And so then that equals, when I integrate it, the inverse sine of u plus c. So I have the inverse sine of x minus 1 plus c. All right, so let's just talk real quick about what we did for this. We needed to get from here to here, basically, or really to here. And so all we did was pull out a negative, complete the square, and we had to do it correctly because we had a negative out in front. And then we use u substitution over here for x minus 1 to give us 1 minus u squared, the square root of 1 minus u squared, which is our inverse sine. All right, I'm going to stop this second video there.